Welcome to Voice Bootcamp, a global name in unified communication. Hello, my name is Faisal Khan, CEO and founder of voicebootcamp.com. In this chapter of CCNA and CCNP Collaboration Self-Study Kit, we're going to focus on understanding the Cisco IP phone. The agenda behind it is connecting and powering Cisco IP phone, VLAN concept and configuration, understanding the Cisco IP phone boot process. We're going to configure Cisco router to provide DHCP to a Cisco IP phone or any other devices. Learn how to configure the Cisco device with NTP for clocking, phone registration process, and quality of service. Cisco IP phone, which comes in various format, various model, connects to Cisco switches just like any other network devices. Now they can connect to pretty much any switches that are standard. There are 4 potential sources of powering a Cisco IP phone. Now obviously if you have 5,000, 10,000, 20,000 phone, you need to have a proper plan of how to power up those devices. You can use Cisco Catalyst switch with a PoE or power over Ethernet, or any third-party switch with PoE is capable that supports standard ITU standard. So IEEE standard of power over Ethernet. Now you can also use a power patch panel. There are some standard power patch panel that are available, PoE enabled. There are something called mid-span power injector. Looks like a switch but not really acting as a switch. It's just simply there to power the phone. And then of course, final but not the least, power brick. Cisco Catalyst switch or PoE are special switches from Cisco system that provides inline power capability on each particular port. The PoE refers to the capability to send electricity over Ethernet capable cable to power a connected device. Now powering device through an Ethernet cable offers many advantages over using a local power supply. Power over Ethernet or PoE became an official standard under 802.3 AF. So if you're buying a switch, make sure that it supports 802.3 AF standard. Cisco inline power is a Cisco proprietary method. Now obviously only Cisco devices, not all devices will support this. The IEEE standard body, which has created the 802.3 AF, not AT, PoE standard, is called PoE Plus. The goal of which is to increase the current maximum PoE watts from 15.4 watts to 25.5 watts. In addition, some proprietary implementation of PoE have reached 51 watts of power by using all 4 pair of wire in an Ethernet cable. Now you also have a power patch panel, a coupler. There are intermediary device such as patch panel that are able to inject PoE onto the line. By using a power patch panel, you still gain the advantage of centralized power and backup without requiring a switch upgrade. If your switch does not support PoE and you do not want to change the switch, then you need to buy a power patch panel. The inline power over Ethernet injector provides a low-cost PoE solution for single device. Those are called inline coupler. So if you have only 1 or 2 devices that needs a power over Ethernet, you're not going to buy like 24-port power patch panel. Just buy an inline coupler. Typically used to support wireless access point and or single spot PoE solutions. Final but not the least, you got the power brick, the traditional power adapter that you connect to the wall jack to the device itself. Now some device will exceed the power capability of 802.3 AF or 802.3 AT PoE standard. In that case, a power brick may be required. When you add a sidecar module on a Cisco IP phone, typically used for receptionist, PoE connection can no longer support the device because of the additional power requirement. In that case, power brick is required. Once the phone is connected, the next step for the phone is to obtain network services. Now, first of all, in order to do that, the phone must belong to a VLAN. In switching environment, a VLAN or virtual LAN allows you to break up a switch environment into a logical multiple broadcast domain. A VLAN is therefore defined as a layer 3 segmentation performed at a layer 2. Common and recommended practice to separate voice and data traffic by using a VLAN. Now, a separate switch and data traffic using VLAN provides an additional layer of security because you can isolate the data from voice, so in case somebody is attacking the data, the voice traffic will not be impacted. Simpler method to deploy QoS. Voice QoS can go to voice VLAN, data QoS can go to data VLAN. You can also prioritize traffic on the router level by saying, you know what, all voice traffic will get high priority. Cisco IP phone will support 802.1 queue tagging to separate the voice and data VLAN. The incoming switch port is able to receive and send 802.1 queue tag packet. Traditionally, a switch port on a Cisco switch that receives tag packet are preferred as a trunk port to a trunk port. Any traffic that remains untagged will be considered as a data traffic. So here's an example of on a switch. First of all, we need to create a VLAN. Second is to assign them. You create a VLAN on a router by typing config mode and type VLAN and then the VLAN number. You can define a name and you can exit. So VLAN 202 for my data, name HQ data. Then I will go to the port where my phones and devices are connected. There I will say switch port mode trunk, switch port trunk native VLAN 202, that is my data VLAN that is created right here. Switch trunk encapsulation .1q, and of course switch port voice VLAN to 102, which is the voice VLAN that's created right here. Now, if you do not require trunk, you can ignore these commands right here, these three commands. Just type switch port access VLAN 202 and switch port voice VLAN 102. Now, Cisco IP phone will connect to Ethernet switch port. If the phone and the switch supports PoE, the phone receives power over Ethernet. As the Cisco IP phone powers up, Cisco switch will detect the attached device as a PoE device, and it's going to deliver the voice VLAN and data VLAN using a protocol known as CDP, Cisco Discovery Protocol. Cisco IP phone now knows what VLAN it should use for its voice traffic via the CDP protocol. Cisco IP phone broadcasts DHCP request, so the phone itself will ask for an IP address by using DHCP. Now, DHCP server, if configured properly, will respond with the IP address offer. When IP phone accepts an offer, it receives all the DHCP option along with that request, such as the IP address, the default gateway, the DNS server, domain name, so and so. One of the most important thing it receives in that address request is called the option 150. Option 150 tells the phone where to, the IP address of the device, where to download the TF configuration file from. Typically, it is a call manager IP address or call manager express. After Cisco IP phone has an IP address of the TFTP server, it will contact the TFTP server, download its configuration file, and it included in the configuration file is a list of valid call processing agents, such as the IP address of the call manager or call manager express. Cisco IP phone attempts to contact the first call processing server, primary server, listed in his list configuration file to register. If this fails, it'll move to the next server in the configuration file. So how do I configure this DHCP? Simple. I will go to the router, which allows the router to provide those IP address. So if I have a requirement to say that I will assign IP address to IP phone from certain range, first thing I need to do, exclude the IP address that are outside the range. For example, I would like to exclude any range for any IP address from 1 to 30 and 51 to 254. So what is available for the IP phone is from 31 to 50. So for that, I will just create IP voice, IP DHCP pool voice, followed by the IP address of the subnet, and then of course the default gateway and option 150. This is the IP address of the router itself. So here's an example of my configuration. So I am on rack 2. So what I'll do, I'll create IP DHCP exclude from 1 to 29. (51) to 54. Now I have excluded everything, so what is available is from a 30 to 50. So I'll say IP DHCP pool voice option 150, IP 142.102.66.254. Default router will be 142.102.66.254, pretty much the same IP address, and the network address. So in a final configuration will look something like this. So you got the option 150, you got default. If you have a second option 150 IP address, you can just put 142.102.66.254 space and the second IP address as a backup. Now, every network devices require a network time properly configured. Time is very important. It is because for logging, security, law enforcement purpose, it allows Cisco IP phone to display the correct date and time on to your end user. It assigns the correct date and time to a voicemail tag. Also ensure that the CDR or call detail recording for billing is accurate time. It also plays an integral part in multiple security features on Cisco devices. Logged messages on the router switches for accurate time information. So to configure Cisco router on a switch to be pointed to an NTP server, you just simply type NTP server, IP address of the server, and the time zone. So this particular router belongs to Hong Kong. So what I'm going to do, I'm going to say clock, time zone, HKG +8. And then I'm going to say NTP server 135.11.11.11. That is my NTP server. And as you can see, as soon as I define the time zone, some clock update took place. And with a little time, if I tap show NTP association, it will tell you that it is connected, was pointing to this particular IP. And this little thing that tells you it is configured. If I type status, and you can see the clock is synchronized. Start time is 3. Reference is the IP address of the server we're pointing to, and therefore your NTP is now synchronized. Now, quality of service. Quality of service is the ability of a network to provide a better or special service to set of users and application at the expense of other users and application. For example, in an organization, CEO and the presidents should get higher priority than, of course, the employee. Designed to keep voice traffic from running smoothly during a temporary moment of congestion on a network. Issues to focus on for voice VoIP traffic are lack of bandwidth, delay, fixed delay versus variable delay versus jitter, and packet loss. The goal with QoS is to provide a consistent, guaranteed bandwidth to voice traffic in such a way that there is a low and consistent delay from one end of the network to the other. So what are the requirements for voice, video, and data traffic? While voice traffic are predictable and remain consistent value for each call entering and leaving the network, such as call cannot be more than 64K or 8K. Actual amount of bandwidth required for voice is heavily dependent on what codec you're using. One-way requirement for the VoIP traffic is to make sure that end-to-end delay should not exceed 150 milliseconds or less. Jitter should be 30 milliseconds or less, and packet loss should be 1% or less. Video traffic has identical delay requirement as a voice, but consumes a lot more bandwidth because of the video part. For data, it is hard to provide an exact value because data depends on the type of applications you're using. Oracle database will have a different value requirement than Microsoft database. Microsoft Office will have a different requirement than Internet Explorer. So it all depends on the type of application. The three methods of QoS mechanism: best effort, integrated service, INTSERV, or differentiated service, DIFSERV. Best effort makes the list simply because this is the model every network uses by default. Nothing much to configure. Traffic comes in and traffic goes out. First in, first out, known as FIFO. Integrated service, or INTSERV, which is provided by reservation. If a call requires 80 kilobits per second to establish, network will reserve 80 kilobits for that call, whether it uses or not. If RSVP reservation fails to allocate the bandwidth, then the call will not be established. The guaranteed bandwidth, but not scalable because every router along the path has to be configured with RSVP protocol, the reservation protocol. Differentiated service, or DIFSERV, which is a class-based QoS. However, traffic is not absolute guaranteed and known as almost guaranteed. Each class has different matching criteria and can be applied different QoS value based on matching classes. Now for classification, for QoS mechanism tool, we'll talk about classification and marking, congestion management, congestion avoidance, policing and shaping, and link efficiency. Classification and marking. Identify the traffic, so therefore classify, and mark the packet with certain value, so therefore marking. Processor intensive because it has to classify and mark, and delay the packet. Marking can be done on layer 2 header or layer 3 headers. Network device look at the marking instead of deep packet analysis in this type of environment. Congestion management is the rules the router should apply when congestions occur, such as drop packets or prevent higher traffic packet to pass through first. Congestion avoidance, on the other hand, where network device will drop enough packet to ensure the network bottleneck does not occur. So kind of an intelligent way of saying, okay, I'm start to seeing the traffic network is getting congested slowly, so I'm going to start dropping packets so that it clears up the road. Policy and shaping, tool that is used to limit the restriction on traffic. For example, you can say that if signaling traffic exceed 50K, you want to drop the prioritization of the traffic. Link efficiency, which is ensure certain link type bandwidth is optimized. Example, slow speed links such as serial interface compressions might help ensure traffic travels smoothly. Following method may be applied: payload compressions, header compressions, and link fragmentation. Link efficiency mostly used on the link that is slower than T1 speed. Switch has some queuing algorithm, FIFO, which is the default, first in, first out, default queuing algorithm. Then there are three primary queuing algorithms in use today: weighted fair queue, WFQ, class-based weighted fair queue, CBWFQ, low latency queuing, or LLC. Weighted fair queue, which is balance available bandwidth among all senders evenly. Higher bandwidth sender gets less priority than the lower bandwidth sender. On a Cisco router, WFQ is often default method applied to serial interface. Class-based weighted fair queue specify guaranteed amount of bandwidth for your various classes of traffic that you define. Example, HTTP traffic will get minimum 20% of the traffic. FTP will get 5% of the traffic. WFQ is then used for all unspecified traffic such as remaining 75%. Low latency queuing, which is often referred as priority queue PQCBWFQ, or priority queue class-based weighted fair queuing. Same thing as CBWQ, class-based weighted fair queue, but it adds a priority queuing to the traffic that are considered to be real time. It guarantees traffic bandwidth that is part of this priority queue, and priority traffic always gets sent before any other guaranteed are fulfilled. Now, to apply QoS, Cisco allows you to use auto QoS, which is QoS configuration done automatically based on one command based on the best practice. Deploys a QoS template in line with the best practice and may need some tweaking to meet your company's policy. It reduces the time to deployment, reduce the configuration consistency, reduce deployment cost, allowing manual tuning, and must understand the concept of trust boundary. Device sending traffic, that traffic might or might not have QoS marking attached to it, or might not be trustworthy. For example, if a traffic comes from a laptop connected behind the phone, well, I may not necessarily trust that particular laptop behind the phone. So I need to decide where to define my trust boundary. Cisco IP phone marks all of its traffic with extremely high priority. Marking are trustworthy because the audio traffic from the phone does indeed need a high priority service. Expert user might configure a computer behind the phone to mark traffic from the same high priority level as a phone does, thus makes it untrustworthy. Trust boundary is a point of a network where you begin trusting that network traffic is accurate and identified with the correct QoS marking. Now, of course, depending on the capability of the device and the network, you can begin applying QoS marking close to the user devices. Cisco IP phone has the ability to mark down traffic as priority to strip any high priority marking from a traffic sent by the attached device. So basically what it's saying that any traffic that is coming in from the PC, any traffic that comes in from the PC, as it comes in, you don't want to trust the PC, so your trust boundary is right here up to the phone. You trust the phone but not the endpoint. You can also put the trust boundary right here that connects directly to the switch, meaning that you're trusting whatever is coming from the phone. Some switch you may not even want to trust, maybe third external switch, something not under your control. So your trust boundary is between the switches that are under your control. To enable QoS can be achieved through a single command applied under interface configuration mode. To enable auto QoS in your network, you must identify the interface to which to apply the auto QoS command. The primary should be the applied interface to which device and appliance needs a special or preferred treatment. Now you want to ensure that you have entered the correct bandwidth under the serial interface for your routers. Interface between the switch and the router with the auto QoS VoIP trust command, because you would consider the QoS coming from the router as a trusted. QoS engineers identify what is being called QoS marking in the previous section, part of your class of service, and type of service marking. COS is marking that exists on layer 2 header of the frame, which a switch can identify. TOS is a marking at a layer 3 header of a packet, which the router can identify. So to configure auto QoS, you go to the interface, type auto QoS VoIP. So I'll go to this interface. I'm going to say auto QoS. Oops. think the iOS in this. I'm going to go to the next router. Sorry, the iOS that I had did not support the QoS command, so I'm going to use it on the switch. So do show run interface 0/8 normal configuration auto QoS view IP trust. Assume that is connected to the router. Then I'm going to say, and now you can see a bunch of additional commands there, right there, for QoS related settings. If I type show run, there are a bunch of configuration now is available that were not there. So all these are QoS related, that is configured by the auto QoS command automatically. Okay. Alright, so that's basically how you enable auto QoS. Make sure you understand where to define the trust boundary. Make sure you understand what QoS marking should be configured. Keep in mind, cause is marking at a layer 2, which switch will identify, and a TOS or TOS is a marking at layer 3 the router can identify. So that's pretty much it for this particular chapter.